Okay, we'll get started. We're a couple of minutes after 11:30. So, good morning, everyone. Thank you for joining Rumsey's ongoing webinar series, typically hosted by Rumsey specialists. However, today we're pleased to be joined by a guest speaker from Rockwell. My name's Sean Huber. I'm one of the automation managers here at Rumsey, and today we're going on the sensor side of our business with a presentation around smart devices, devices to dashboard. So a lot of value about how to get information from the very bottom, most basic pieces of the plant floor up to places where you can use it. I'd like to then take the chance to introduce JJ Tiara from Rockwell. JJ is the Global Marketing Manager for Sensing and resides or works out of the Chelmsford, Massachusetts area. With that, JJ, I will turn it over to you, and you can take off with the presentation.
Thank you, Sean. And thank you, everybody, for joining. I will be going over smart devices and how Rockwell is in a unique position to provide a great value for the connected enterprise. I'm going to show devices such as sensors and how to bring all that information, how it comes all the way to a dashboard. I'm going to go through some slides, but then I'm going to demonstrate the sensors and also the dashboard features. When we look at the environment today, is my complete screen visible, or is it being blocked by something?
I can see the complete screen.
Okay. When we look at the environment out there today, the relationship between OEMs and users is more of a partnership for production. The capability to deliver the value over the lifetime of the system is more and more important, not just at the installation time, what the cost is. And also there is strong push for prescriptive maintenance. Now, that means that you know the issues and then know what to do about them. If you have diagnostics coming back from the devices, then you are able to go to the next step of preventing, predicting, and also, once you know all that, you can make it what to do about it. Make it prescriptive maintenance. When we look at the machine builders, they have the challenge that, well, is my equipment going to perform, meet the expectations for performance? Also, how can I differentiate my equipment, my machines from other suppliers? What can I offer more? Can I help the customers in preventing problems before they actually lead to downtime, before they become a fire trail? The downtime cost is very high at plants. It depends upon what kind of a plant we're talking about. A brewery I visited, they said it's $110,000 an hour. Other plants would tell you completely different numbers. Maybe it's only $10,000 an hour at one plant. Auto industry tells the highest numbers where Ford says it's $1 million an hour. That's at a F-150 plant. And at an Escape plant I visited, they said Ford Escape, they said it's $600,000 an hour. But let's talk about a plant which has only $10,000 an hour. Is it only 1 hour of downtime at a plant? No. Over a period of a year, it's several days, several hours built into days. I was attending one of the sessions earlier, in which BAM session, where they said that on the average, it's 3.5 days of lost time. That easily comes out to about $1 million, even if it was $10,000 of lost time, lost production time. So that's what, if we were able to prevent that by providing diagnostics info so that you can take care of the issue before it becomes an issue, before it leads to shutdown, then we have achieved something. end users are looking for the challenges there are performance, of course, that is the machine going to do the perform the way it's expected, good quality product produced, and tell very quickly when something does go wrong, what's wrong and where has it gone wrong. Cable problems. If a cable breaks or shorts out, they are usually very difficult to find. And if it's intermittent cable problem, it's even more difficult to find, as you all know. Other things the end users would look for, hey, how do I prevent problems before they cost me production time? So the business drivers, when we look at for smart manufacturing or all this, is exceed the productivity goals on the side of the users, improved asset utilization, looking at lower overall cost of ownership, producing products faster. All those are business drivers for the end users. They also want flexibility in machines where today they are using this equipment, let's say for a certain size of bottle, next day they might be able to use a smaller bottle, make changes, flexibility. Now on the OEM side, they are they able to provide equipment which is flexible? What kind of operating equipment efficiencies, performance the equipment's going to offer? Of course, differentiation comes in. How do they drive innovation and differentiation into their machines, into their equipment? A lot of the OEM systems integrators are already doing it or looking into doing it, subscription models where they will provide aftermarket service and support to their customers and be able to, now if they were able to troubleshoot the equipment remotely towards providing that service, it will make the task a lot more easier and possible. In these COVID-19 days, everybody working from home and all that, it's become even more important. A lot of that is getting done online these days. It is true that some of the end users will not want their equipment to be monitored remotely all the time. And security reasons, of course, very valid reasons. But when an end user is losing $10,000 per hour or $100,000 per hour, they can selectively give that access at that time so that it can be taken care of remotely instead of having to wait for somebody to come in 2 days. So total cost to design, develop, and deliver is an objective the OEMs have also that to offer that to their customers. Looking at the Rockwell's vision for smart manufacturing, connected enterprise, for smart plants, the real-time information is coming from the plant floor to the people who are managing it. In order for the plants to be smart, the equipment which is in there, the machines which are in there, the conveyors, and everything installed over there needs to be smart to provide that. And for that equipment to be smart, the devices which are going on there need to be smart, whether they're sensors, motor controls, all those items need to be smart, and that's how they will be able to create a smart plant and get to the vision, connected enterprise. I'm showing one machine here. If we knew the voltage, the kilowatt hours, the running time, the temperature of various things on that equipment all the time, if we were able to monitor that, we'll be able to see if some problems are coming up and take care of it before it actually occurs. I've highlighted margin. Margin is a term used in sensors, but it's also used in a lot of other equipment. On a photo sensor, dust builds up on the sensor on a conveyor, for example. Soon the sensor will fail, and that'll of course lead to production loss. If the maintenance team is advised of that and they clean the sensor, that problem is prevented. No shutdown. Preventive maintenance, that's great. That's the idea for bringing in the information. And the differential value of the smart devices it increases over the lifetime of the system. As you can very well see how it will increase during the operations as it reduces the downtime. But I'm also showing value here in the design part of it. A lot of OEMs and a lot of users would say that, well, actually to design in a sensor which is just giving you on-off as output is easier versus designing in something which requires setting up for smart sensors. What I'm saying here, the value in design, and I will show it how as we go through this, is that when a company makes the decision to do digital transformation and plant is going for smarts, in that case, how we offer that it's easier to design that, implement that with our Rockwell's solution versus others. So what makes devices smart? Is it just the sensors that's providing that info or devices are providing? No. There are several things which go into it. What kind of enabling technologies, what kind of user experience and analytics is available. So I'm going to go through very quickly through each one of these. Device information is definitely coming from the device itself. Best info, the source is the device itself. Low pressure. So the pressure sensor is going to give that info. Dirty lens. Proximity sensor and the target has drifted farther away than the specified sensing range. Temperature sensor. So all these things are coming from the sensor. So the best info is coming from the sensors. And all devices are not equal. Our sensors would offer certain features and more features perhaps than versus some others. Within our sensors also, there are different sensors with different features sets offered. The latest sensors have the most diagnostics info coming back. I'm showing here some of the examples. Photo sensors on the left-hand side. On day one, when a sensor is installed, let's say there is a reflector at 10 feet from the sensor. Margin of 10 means that signal which is being received at that time is 10 times the minimum signal required for that sensor to operate. It's pretty good. But on day 10, as the dust builds up, I'm showing that margin drops to 3, means the signal level has gone down now because of the dust buildup. And it's only 3 times the minimum required. Pretty soon, that's going to drop below 1, margin of 1, and the sensor is going to stop operating. If a reflector is misaligned, that does the same thing. It reduces the signal level coming back. On a diffuse sensor, it's the same way. Sensor gets dirty, it will start going down in signal level. For inductive sensors, proximity sensors, the specified sensing range, one should never use it more than 80% of the specified sensing range because the last 20%, not enough signal is coming back. It's margin, low margin. It's still working, but it's low margin. And the targets do end up drifting farther away or sometimes come and even hit the sensor. So if it drifts away, goes into the 20%, the last 20%, we send a margin low signal, saying alarm signal. And if it comes in on a barrel style sensor, it comes too close and hits the sensor and damages the front end of the sensor, no longer being now detect a target, we send a message back saying the sensor front end is damaged. Internal temperature of the sensor is being monitored as well and kept a record of, and that tells if there are things going wrong. So all this is diagnostics towards predictive and preventive maintenance, margin low, temperature, low pressure. And I mentioned one more thing, received signal level. On some of these sensors, we even have the signal level, what level of signal is being received. For example, I have a diffuse sensor here. The signal level coming in here is more versus here as I move my hand away. So it's not analog signal coming back, but there's a digital signal coming back, which is telling approximately where the target is and how much light is coming back. We have that in the sensor, which is the inductive sensor, flat pack sensor on the right corner, right top corner of this slide. That also has the same feature that the target is drifting away, but if the target's coming too close, You also get a high signal level, and actually you could set an alarm for that as well. The technologies used for this are IO-Link for the sensors. CardLink is our technology, which we use for the safety applications, and I'll go through a little bit of that also. Now, both these, they are not networks. They sit beneath the network. Ethernet IP is the network that we have employed and for all this. And then we have the Studio 5000 with add-on profiles, all this. And it makes for the seamless flow of info from device to dashboard, where it'll provide the largest value. What is IO-Link? I think all of you are familiar with it. I'll just very briefly go through it for those who may not be, how it operates. It's point-to-point communication. It's an open standard, IEC standard. It's not a network, point-to-point to the sensors. I'm showing a sensor here with its connector. One of the pins, pin number 4, is always the output of a sensor. If you connect it to a standard input module, SIO, I show it, you see the output being just the two conditions, high and low. Now, if you connect the same sensor, if it has IO-Link in it, if you connect it to an IO-Link master, that's what the terminology used is in the industry, then it starts sending the pulses as you see. That serial data communication is per the IO-Link standard. Each bit contains certain infos, like one bit would be for the output, another bit for margin low alarm, another one would be, hey, there's something nearby, proximity. The other bits may have the catalog number and other items. It's forwards, backwards compatible, meaning that you can take a sensor which has IO-Link in it, you connect it to a standard input module, it'll work just as on-off. If you connect it to IO-Link master, it'll just start working, sending automatically, communicating data, all kinds of diagnostics and all that. The masters are also designed to be forward, backwards compatible. You can configure each channel. It can monitor an on-off standard sensor or a sensor with IO-Link. Beauty also is that the cabling is the same. No change in cables, not like DeviceNet where you require special cabling. And we have kept the prices of the sensors the same, so it's not higher price in sensors either. As we added the IO-Link, we did not change the pricing. There are two different ways that we offer IO-Link in this solution. One is in-cabinet solution on the left-hand side. The point IO base, if some of you may be using it, 1734-AENTR, the point IO base. And I have here plug-in modules shown at 1734-4 IOL, which is the IO-Link master. It's a 4-point device. This can monitor up to 4 units, and you can stack these up to monitor more sensors. Photo eyes connected into it, inductive sensors connected into it. Not only that, measurement sensor. If that measurement sensor has IO-Link capability in it, then we don't use the 4 to 20 milliamp. You connect it to the same module, and it's sending digital data information directly for pressure and PSI. If it was a laser measurement sensor or a measurement sensor, it'll send you directly the distance. No need for scaling. 4 to 2, what's my 4 milliamp point and what's my 20 milliamp point? No need for doing that. No shielded cabling required either. Why? Because these signals, which I mentioned, they are very robust signals coming back, 0 to 24 volt signals coming back. So all that is being done by that single module. Don't require an analog input module, which is a lot more expensive than the IO-Link master. So there is upfront cost reduction when you're trying to do analog, replace the measurement sensors with IO-Link sensors. I'm also showing that you can drive outputs, actuators. So if there's a valve bank and multiple valves on it, if it has IO-Link attachment to it, which currently a lot of the suppliers are already offering, for example, Festo, SMC, and Aventix, all of them offer that. Single cable, single point of the module, you can drive multiple valves with a single cable going out there. That is a huge, huge cost reduction as well. And looking on the right-hand side, that's our in-cabinet solution. On-machine solution is this with this armor block unit on the right-hand side. This shows 4 connectors, but with a splitter, you can actually connect up to 8 devices, sensors to it. And this can, on the top, you see 2 connectors. This converts everything to Ethernet IP. So the signals come in IO-Link, they get converted to Ethernet IP through these masters. Same thing on the point IO master. And this one has 2 connectors on there, and so device level link can be done as well with the Armor Block Master. Armor Block Master has some additional features, time stamping. It'll tell you what time exactly certain thing happened. A connection got broken, or a sensor got low margin alarm, or things like that. I'm showing a valve bank also that you can drive valves with it. One needs to be careful that the current is coming through the master, so need to be aware of what the maximum current coming from that is. Overall, the overall architecture, device to dashboard. So on the left-hand side, I'm showing devices which are sending IO-Link signals. The 2 arrows are the IO-Link symbol, represent the IO-Link symbol, and getting converted to Ethernet IP through the master. And then once on Ethernet IP, you're connected. You're connected to remote. It's the Industry 4.0, the connected enterprise. And you can be connected to mobility devices as well. And we are going to go through that demo a bit later. On the right-hand side, I'm showing certain devices which we already directly are on Ethernet IP, such as our encoders, the RFID system, and also the code reader, which we announced about 2 months ago. Is directly on Ethernet IP. And my demo setup, quick explanation. I have 4 sensors here on the left picture, and I will be going through them. And then I have a panel view plus display, and I will be monitoring, bringing that screen over to my laptop to be able to show it to you. And then on the right-hand side, I'm showing that I have a Compact Logix L1 controller on it. I have a point IO base sitting behind my demo. And I have 2 modules, IO-Link masters, installed in that, although I'm using only one for monitoring 4 sensors. The center picture here shows the Armor Block module, which we discussed earlier, and also showing a second module here. That is IO-Link Hub. We offer 3 different hubs, and this is one of them. It's got 8 connectors on it. You can monitor 16 points by putting a splitter on there. So you may be monitoring limit switches, push buttons, or sensors where you don't need diagnostics coming back. You could monitor. The signals coming into here are converted into IO-Link, and from that connector on this IO-Link hub, you connect that to one of the ports on the IO-Link master. So now with 1 point, you are monitoring 16 devices there. Huge cost reduction, huge wiring reduction in installations, IO reduction and wiring reduction. However, big thing to be noted is there is no diagnostics coming back. So all the goodness which comes with the diagnostics for preventive maintenance is not there when you're using an IO-Link hub. However, there are places where it can be used where diagnostics is not to be brought back. We offer 3 different models of this device. On the right-hand side, I show my demo, and on the back, there is a unit sitting there, which I have 24 volts power coming to it, and in an Ethernet cable that runs into my demo. So that's connected to my demo. That appliance is known as FactoryTalk Analytics for devices, and we'll be demonstrating that also. Let me go on to my demo of the sensors. The various features which we have designed in for preventive maintenance, and then beyond that, once you have found a fault, how to fix it quickly. Let's go on to the diagnostics part. This screen enables me to show various features. I'm going to the diagnostic side. I have 4 sensors connected. They are showing good connections, as you see over there. And I have also, on the 5th one, there's nothing connected, so it's showing failed. Here's a sensor, right side sensor. And right now the output triggered once says it is off. I'm going to put my hand in front of it, and you see that, okay, the output has turned on, the yellow light's on now. And if I remove it versus bring it in, and it says output is on, but it also is showing margin is good. Another green light message over there saying margin is good. I can create a dirty lens condition here by moving my hand away, so the signal level received is less. You notice that it's come in and saying that margin is low. So that signal has gone back and been sent to the HMI as well as PLC, and so everybody knows now. That is the preventive maintenance time. I was at a tire plant where they were having issues when the tires come off the curing press. They are hot. They go into a cooling area, and the area is kind of, collecting all kind of black dust. The sensors fail to detect two tires hit each other. And once they hit, both our tires are ruined. Their annual losses in that, the 10 tires lost minimum per day, $350,000. They implemented this solution to get the performance, and I'll go further into details later. But that's the preventive maintenance part of, well, what happens if the connection, today, if on, off, that's what the output of the sensor is. If the connection breaks, you don't come to know. Here, I'm going to disconnect this sensor, and as I disconnect it, I think you cannot, the cable doesn't reach in front of us. And right there, right away, it sends a message saying, hey, connection's failed. And it tells you which sensor, where the connection has failed. Let me put it back. Normally that, you don't come to know that. We also put in a feature near object. When the output is about to turn on, it tells you, hey, the output is about to turn on. That may be a valid signal, or it might be that, hey, why is it that the sensor's output is so close to a trip-on point? I have a laser measurement sensor here. That's the center row of the screen. I'm measuring it to the wall over there. It's measuring 1290 millimeters. This sensor has a 25 feet range, 8 meters sensing range. You can set it up that I want to see only up to, let's say, 1500 millimeter and nothing beyond that, and you can do that. There is an on-off output on this, which will come on, and output is on when you see something within that range. However, I'm showing two outputs here, triggered 1, triggered 2. I have set this up that if you see something at about 1 foot, I'm at about 1 foot from the sensor, 300 millimeters, and output is, one of the output is on. There's another virtual output in there that if you see something at 2 feet, now I'm at about 2 feet, and another output is turning on. You can create multiple windows, so you and get multiple virtual outputs. You can, now we have added functionality. You can do more things with the sensors with having done that. So the first part was the preventive maintenance part of it. I'll go on performance features, enhanced performance as we go along later. Next part is what happens if a problem has occurred and now somebody has to go and change the sensor. First thing is, how does he find which sensor to change? What function has stopped performing? It's a lot of times it's very difficult. Several sensors are installed on the conveyors and all that. Which one is causing the problem? We have created a field in here which we call application specific name. You can assign a name to a sensor, and then it's a 32 character field. I'm going to change this name to something else and write that as the name for that sensor. The idea here is that you, with that field, you may say, this is my in-feed sensor, this is my out-feed sensor, this is my jam detector. Give the terminology which is proper for the machine or the conveyor, and so that it's easy for the guy to see where the issue is. For example, it might just say, hey, it's photoelectric PE2, conveyor 2. So idea is, tell a third shift, second shift guy who may not know exact functionality of all those sensors, which sensor has caused the problem, he can easily find that. Once he knows that, he goes to the plant floor, or to the machine, and he's trying to see what's the catalog number on that sensor so that he can get that from stockroom. He looks at the sensor, was probably there for 5 years on the machine, and the catalog number is not legible. And he doesn't have to do that because the bill of material is right in front of him on the HMI and coming through each sensor from through the iLink. Also, we have created faceplates, and I'll show both at the same time. Here is a faceplate for the iLink master, which is the point IO master, 4 points point IO master. If I click on it, it'll show me 4 channels. And if I go on each channel and I look for it, it'll give me the catalog number associated with that channel and the application specific name. So the guy didn't have to go out there. He has that information. So this is all time savings in trying to get it back, the equipment back up running. And these faceplates are there so that people can take it from our sample code library and just plug that in. They don't have to design their own faceplates. Looking at next step he has is he gets the catalog, that particular sensor from stockroom, and goes to replace it. And now he says, how do I set it up? Potentiometer or push button, how do I teach the distance? Or was it light operate or dark operate? Was the push button locked or unlocked? All those decisions, and who's going to find all that data and how long time he's going to spend in trying to do all that. Automatic device configuration, which is also in our drives, is a feature which we have in sensors as well. You see this sensor, the 42JT VisiSight sensor, it is showing right now over there a reading of 900, and this sensor detects me with that setup. It detects me up to about, I'm not sure what the LED is visible, but it detects me about 3 inches. When this sensor ships from the factory, it has a sensing range of 32 inches to 90% white, 90% reflective target. I can't right now here change this sensor and do the demo, but the 900 setting is the internal threshold setting for that sensing range. When the new sensor is brought in, you remove this sensor, you install the new sensor, and right away, instantaneously, it's going to take on 3 inches as a sensing range. Whatever was the setup, the 900 setup is stored in the PLC. It gets downloaded automatically, instantaneously into the sensor. At the same time, it downloads whether it's a light operate or dark operate, whether the push button on the sensor was locked or unlocked. On the right side sensors, we have potentiometer. So when we're redesigning this, we designed it in a manner that you can actually set the sensor with the potentiometer, store that setting in the PLC as for automatic device configuration. When a sensor is to be replaced, all you have to do is connect the other new sensor, and you don't have to touch the potentiometer at all. You can actually disable the potentiometer also. A lot of the plants have this issue that when something goes wrong, people tamper with the potentiometer, and then you can't even find what the issue was. So you can make the potentiometers, the knobs on these sensors, tamper-proof as well with the iLink capabilities, the smarts which we have put in. All this is towards reducing the time once a problem has occurred. Let's say you have, I'm going to go through, extend this to multiple profiles or multiple recipes. For example, a color sensor, you have different products on the floor to be run, and you have to change the settings teach the sensor or change the settings on the sensor when a different color mark is to be detected. One could actually teach that sensor multiple profiles, multiple recipes, and store them in the PLC. And then when the product is to be run, he just has to select the right profile, right recipe from the HMI and download it. A thing which takes probably shutdown of an hour or more, depending on how many sensors and all that, can be done instantaneously by doing it this way and reducing downtime. We talked about, how do we reduce the design time. We have already created, and this is one of the ways to do it, one of the things which we do to reduce that downtime. Controller tags are already created. You don't have to be deciphering which the data coming back in bit stream, which bit is giving me what. That's already been done and contextualized. Output is triggered, margin low alarm, proximity near object. All that is already done by us. Now that won't occur with sensors which you can connect other sensors into our masters and all into our systems. But this controller tags and all that information will need to be created, whosoever is implementing it, and that's not done for the others. Let me go on to some of the other features, advanced features, which we have in sensors. This is the right side sensor I'm looking at again. And you see the actual temperature inside the sensor at present at 49 degrees C. Maximum since inception is stored in there at 61 degrees. So it is keeping a record of what's the max and min temperatures and also the current temperature. It's also keeping a record of how many hours this sensor has been in operation for since inception and since last power up. All that is very valuable information when things go wrong and you're trying to get a plant back up and running or things are providing issues. Now, you don't have to be bringing all this data all the time. You can selectively bring all this data. There is one other feature. What happens, there are sensors on the plant, which is several sensors on a line and on a machine, same type. You have a problem and the sensor is sending a message that you got a margin low alarm. How do you find which one on the machine or the conveyor is that? Location indication. We have a feature. I'm going to click on that. And here you see that from this side, I've triggered, the sensor is flashing LEDs. This is easy, making the guy go out there and the sensor is telling, here I am. In the meantime, the sensor is operational. The output is turning on and off. So it's all preventive maintenance and making the task easier for the guy to locate the sensor. I was at a distribution center. Every 30 inches on the conveyors, there are sensors. When there is a problem, they have issue even trying to get to know which sensor is giving that issue. They love this feature. So did the tire plant example, which I was mentioning. They also implemented this additional thing to get that. We also send the signal level from this sensor, and I'll go through some use cases for that as we go along. Let me go on to back to my PowerPoint and discuss what's being done in the safety side. In safety, the devices are wired in series. So when the devices are wired in series, when a device trips, it's hard to find which one is causing the issue, and you lose time trying to find that. So the idea is, how do we help in quickly finding where the fault is or where the issue is? Here I'm showing GuardLink. I'm showing one string of items over there. Actually, you can have up to 32 devices, and with the smart taps installed in there, any device which trips, it tells the information to the GuardLink relay that that particular device is the one which is causing the safety system to go down, the safety system to send an alarm. And there are two. I'm showing only one string, but there is on this relay, there can be two. So up to 64 devices connected, and you can have this whole thing 1,000 meters long, and devices can be up to 30 meters apart. The gray module you see right next to the relay module, the red relay module, converts that data to Ethernet IP. And once on Ethernet IP, it's communicated back to everything. So that's how the safety architecture is. And overall architecture, very similar to the one which I showed with the IO-Link sensors, that devices send the signals to the GuardLink relay, gets converted to Ethernet IP. Once on Ethernet IP, you're connected, even all the way to mobility devices. On the right-hand side, I show some devices which are directly on Ethernet IP. When we look at overload relays, traditional overload relay, it'll prevent the damage to the motor, but production's down. It's purely reactive maintenance. E300 smart overload relays, on the other hand, monitor, the primary function is the same, but the runtime, the current is being monitored, and increase in current is conveyed, and one can now, with this kind of diagnostics, do predictive maintenance, do preventive maintenance. So again, helps in preventive maintenance and gets rid of the production downtime, reactive maintenance mode. Overall architecture again is the same, that getting onto Ethernet IP and then getting onto all the way to all kinds of devices, including mobility devices. When we look at what do you go through in trying to implement all this, that's the user experience. And what do we offer from Rockwell's side? Rockwell offers sensors, masters, iLink masters. We offer the controllers and the software. So we are able to do premier integration. A lot of the other suppliers either offer the sensors and the masters or offer the controllers and the software. So it's harder. How do they integrate? Can't. With our premier integration with Studio 5000 version 20 and up is where we've done all this with add-on profiles, controller tags created, view faceplates, which I'm going to show, view faceplates created. Also device discovery. You connect the system, it'll automatically, iLink Master would automatically take the info on what devices are connected for Rockwell devices. And automatic device configuration, we already went through. Timestamps, I mentioned that it tells you what time certain thing happened on the Armor Block Master, which means, let's say a problem occurs and you have started producing bad quality product. Why did it happen? When did it start? And so that you can set aside that product, you can look at and see in time where that issue occurred by looking at the history on the events and the data stored. Add-on profile. I'm just showing a screen to give you a feel that you're working in the Studio 5000 environment, and with add-on profiles, making it easier for setting up the sensors and versus other suppliers. Now, what will the other suppliers do? They will give some sort of add-on instructions to be able to do that. But it's not the same experience as you have with the Studio 5000 and the add-on profiles with our sensors. And the view faceplates, I had shown one of them for the iLink Master, the 4-point master, but that was for Panel View Plus. We also have these for the View 5000 and the Machine Edition, FactoryTalk View Machine Edition or Site Edition. Now, in the last 6 months, we have introduced 6-7 sensors. Some of the faceplates are being developed now for those, so all of them are not ready, but they are coming out. Last but not the least, how do we put it all together? Analytics. How do you manage a place where you got 1,000 sensors or 1,000 devices and you are trying to monitor all of them, and how are you going to really do this? We have this device, FactoryTalk Analytics for devices, and we have this appliance. It's sitting in the center of my screen here, analytics appliance. At the bottom is the devices such as sensors, other motors, and the drives, and the PLCs. And at the top is the displays, HMIs, or even mobility devices. This device is capable of monitoring, the analytics appliance is capable of monitoring up to 100 Ethernet nodes. It'll check what's connected on those. Is there a problem on any of them? The first place which they tell me was installed at a brewery, it picked up a battery was low someplace. It picked up some software should have been done in full duplex, was done in half duplex. It picks up those type of issues and brings them to the fore for the maintenance people to attend to. I am going to go into a live demo of that, how it is looking at the sensors. So let me once again escape out of this. And I had mentioned that I have connected this thing. This is the screen coming from that device. By the way, I didn't have to do anything. I basically connected that unit with the Ethernet cable to my demo. And it's picked up that I have a Panel View Plus 7. I have a 1769 L1 controller, L18 controller. I have a power supply. I have a 1734, the point IO base. And then I have the 4-channel IO-Link master. There is a second master here, which is showing failed, but that is because I don't have anything connected to it. And I'm going to go, looking at what's coming from this master, and it's showing me what's the status in there. But let's create some faults. I'm going to take this sensor, which is the 42JT, one of the sensors, and I'm going to disconnect this sensor. As I disconnect the sensor, and I'm also going to take my right side sensor and again create a low margin condition on this sensor. By the way, there is a message has come in saying IO-Link device is either not connected or not operational. So the disconnection of that sensor, and now a second message comes in. The 42EF sensor is about to fail due to insufficient light being received. How great is that? It's telling, and it's telling it's channel 1, channel 3 at the top. It's telling which module. So it is telling you exactly which sensor is giving you the problem and what that problem is. How cool is that? It's coming to your HMI, and you can now take care of it. You're not monitoring this every sensor or every device in the plant. It's telling you what to monitor, what is causing the issue, management by exception. There is an action deck screen on here, and that is getting the same messages coming back, and these are the action deck. And once the issue is resolved, you'll get a message also saying the issue has been resolved. So that's how the guy is getting all the messages all the way to this dashboard. Let's go one step further. We have a free app for the mobility devices. I have it on my cell phone as well, on my iPhone. It's called FactoryTalk Team 1. FactoryTalk Team 1. In this app, if I go to my action deck, it's sending the same messages to this as well. How cool is that? That means a person in the factory, a maintenance manager, can set up his team of people who are going to be assigned, let's say, the tasks based upon if a message comes through, who's going to go and take care of it. And once that's taken care of, the message gets sent to the manager as well as to the people that, okay, it has been taken care of. That is our device to dashboard. That, when you look at various other products being offered, this kind of message data is not coming all the way through what we are being able to do with our overall device to dashboard offering. And I'm going to go back to PowerPoint and show this is because I wasn't able to do a live demo of this. Normally when I'm visiting, I can. Here I am not connected through Wi-Fi. I'm connected through hardwired connection because of speed issues with Wi-Fi. So I'm not being able to bring my live screen over there from the phone. But this is a slide showing that how the messages are coming all the way. And it's a free app. Just very quickly, I'll go through some of the use cases. This I have already gone through the savings at a tire plant. As a matter of fact, they are using the low margin alarm indication and also the location indication features. And I did visit that plant about a month after they had installed it. They have a reflector installed at 6 feet, and they are using the 42AF, the bigger right side new sensor, which we have. That has a sensing range to that reflector of 33 feet. The reflector is mounted at 6 feet. So it's sending a very good signal. But as the dust builds up, sensor gets dirty, and they get an alarm. Now, they even changed the threshold. Whatever we had set up in the sensor, they were able to, through IO-Link, you can change the threshold. They wanted the alarm to come on earlier so that they have more time to go and take care of it before, and so they were able to do that. And they have the location indicator feature also because they have several sensors installed on those conveyors. Actually, those tire plants have now decided, they have 14 plants around North America, and they have decided that they are going to gradually change over all sensors to be smart sensors so that they can see the issues and before the shutdown occurs or they create more scrap. This is signal level strength coming back. when we pull out a paper out of a tissue box, the next one is ready to come out because there is a sandwich, second layer is in there. When they are doing it in the plants, they want to make sure that those are properly packaged. They have mounted through beam right side sensors like this. If there is nothing present in there, maximum signal is received. If there is single layer of tissue, it cuts down the signal by about 20–30%. And if there is two layers, it cuts down by 50 to 60%. They set the threshold in the PLC, and now they can actually detect 3 different conditions. But not only that, that's a very inexpensive way of them doing this thing, and they were able to eliminate some expensive equipment. I know of other companies as well, at least one other company which is doing it the same way. I was given an issue at an auto plant where embarrassing situation occurred for a company where they shipped a vehicle and a customer got all the way to a customer with front seats as leather and rear seats as cloth. Quite embarrassing situation for them with all kinds of checks and balances, error proofing and photo and videos and all that, cameras and all that. This happens. We offer them that right side sensor, diffuse sensor has more signal coming back from leather versus from cloth. Just very inexpensive solution, and they will be implementing it. I did visit that plant. They had already tested by that time that the sensor can do the job. So there are more applications now that can be done as we are doing this with the received signal strength. This is the example of the plant, the distribution center, where they have every 30 inches there is a sensor installed. This was a plant where 11,000 or so more sensors were going in, and they have issues. They need to make same day shipments or next day shipments. And if a sensor gets cable is wiring connection issue or reflector getting damaged or knocked and misaligned, or a sensor getting dirty, they don't come to know till the things start falling off the conveyors. And then they lose time and miss the deliveries, miss the shipment schedules. They were revamping, not revamping, but they were adding to the plant, and they installed all kinds of controls and conveyors, new conveyors going in. They asked me for which sensor, and we offered them the right side sensor. The OEM connected those the OEM put those sensors on the conveyors. Actually, they future-proof the installation. The sensors are the same price. However, the cost of per point for the masters makes it higher. So that makes it a problem for the OEMs to initially consider installing this, because they believe that that might make them not competitive with their other suppliers. So they may shy away from it. However, this end user future-proofed his installation. They didn't have the budget for installing the masters. They said, we'll put that in the budget next year, but we'll have the sensors. We already have the Rockwell controls going in. OEMs, SIs can take the same approach, and some of them are doing it. They are using Rockwell controls, using Rockwell sensors. They doesn't add any cost upfront to the equipment. They can later upgrade the equipment for their customer as the customer sees that, hey, this can be beneficial to me for reducing scrap or reducing downtime. So those are different approaches. Both can take, the end users as well as the OEMs and systems integrators. By the way, this plant also, you would say that what is if the sensor is supplying the output to the zone control module, then how do you get the output to the IO-Link master? Well, a lot of our sensors have 2 outputs, and the right side sensor also has the 2 outputs, light off, dark off. So they get the message. One of the outputs, they connect it to the zone control module, and the other one goes to the IO-Link master for all kinds of diagnostics. This is very straightforward that, analog input module is more expensive, more higher in list price versus the iLink master module. And you don't need shielded cabling either, and you can use the standard cable. So there's upfront cost reduction. And this is using at a paper plant where the 45 DMS laser measurement sensor, which sends you signal quality information, is being used. So no doubt that it's easier setup for the analog sensors. Instead of using analog output, use IO-Link output. Setup is a lot more easier directly, as I showed you on the earlier in the demo. But signal quality info allows them that instead of having compressed air being thrown at the sensors all the time in that paper plant, they can now do it with selective cleaning. In compressed air cost is rather high, and it's operational cost savings as well, in addition to the upfront savings for the link master being lower priced than the analog input modules. Simplified valve control, we already discussed that a little bit, but I'm showing a right-hand side picture which shows wiring to a valve bank where, let's say, multiple valves are there individually being driven. In the left-hand photograph shows the one of the valve banks with an IO-Link attachment to it. A 4-conductor cable brought to that module will be able to drive multiple valves. And in the valve wiring's costs gone down, as well as troubleshooting, and everything is so simplified. They started out with the 1734.IO, but now that particular application, they are using they have tested it with the armor block master, and enough current is coming. They are being able to drive 14 valves, and they have tested the speed as well. But initially they started with 1734, and that was reducing the cost by 25% on materials, and labor was huge reduction as well. So gives you a feel for that. This is a Tortilla Counter Stacker machine application where they are being able to see if the dust flour has covered the sensor. All these are kind of giving you some examples, but the truth is I would like to know from your side as well if you see some applications. Normally when I'm in the field, I like to review the applications and see if there are unsolved applications which we are now being able to do with additional capability built into the sensors. Differential value of smart devices, as now we can see, it increases over the lifetime of the system, and we offer this all the way from a device to a dashboard. People do ask me, well, I'm using Aussie or something else. First thing, Aussie is a network. IO-Link is not a network. IO-Link is point-to-point communication. Second thing is, we are talking about device to dashboard. Is Aussie going to be able to do that? Or we cannot. It can't. So that's where we are at present. Great. Thank you very much. I might have gone a few minutes over.
I think we're right at the end, JJ. We started a couple minutes just late just to let everybody go on. I guess with that, I know you covered a lot of different things the whole way from sensors, maybe looking at the inputs and capabilities a little bit different from the sensors, from temperature and stuff that obviously the dirty lens. But other things that maybe you wouldn't have thought of historically, all the way up to FactoryTalk, analytics for devices. So, there's a lot of pieces in between there. So if anybody has questions on any one of them, that's what our specialist team is around for. Feel free to reach out. But at the same time, since we do have everybody on the line here, if there was any questions, feel free to unmute yourself and we can ask JJ right now. So with that, I'll just stop for a second and see if there's any questions that come in. All right. And with that, I know typically as these things go, you'll think of different ideas or concepts. Feel free to reach out to us. As I had said when we opened this webinar, you will be getting a copy of this presentation, a copy of this recording, as well as the supporting documentation that JJ has talked about on everything here over the course of the day. So you'll have some quick links to items to get into more depth on them. Any final thoughts there, JJ, or we can sign off?
Yeah, and you know, as I'm not too far away from your area, as the things open up, if there are opportunities and you see the need, I can travel because I won't take a flight, but I can drive down to your area. Keep that in mind. If certain customers would like that, I can look at the applications and help. But thank you very much. Thank you.
All right. All right. Well, with that, thanks everyone for tuning in today. We will continue these topics, varying topics, every Tuesday, kind of well into the future. If you have any questions on any of the stuff that comes up, just email your specialist and/or salesperson, and we'll definitely get back to you with an answer. With that, thank you, everyone. Have a great rest of your day.
Thank you, Sean.